Recently, I was very surprised to learn that there is a problem when it comes to measuring the speed of light. Now, I got my bachelor's degree majoring in physics, and I never heard about this problem until very recently. I was always told that the speed of light was very consistent and that it's always been known and very easy to measure. But it turns out this isn't actually true. So when it comes to measuring the speed of light, you can only measure it as a round trip. So it has to go somewhere and come back. You can't measure the speed of light directly. Now, just to prove that this is a problem, when you go to the Wikipedia page for the speed of light, it talks about the problem right here. It says it is only possible to verify experimentally that the two-way speed of light is measured, and it is impossible to measure the one-way speed of light. So that's what I want to look at today. So I just want to explain this a little bit more clearly. So I want you to imagine that there is a laser that's going to shoot a light and be capable of measuring it. So that laser shoots out a light, it bounces off a mirror, and then it comes back. And you measure the time, and you're able to know the speed of light based on that. Now, let's just say that it takes 4 nanoseconds for that light to get there and back. Now, when it comes to physics, what we would always assume is that the speed is constant, that it takes 2 nanoseconds to get down and 2 nanoseconds to get back. But because you're only measuring the round trip, there's actually no way to prove that it doesn't take just 1 nanosecond to get down and 3 nanoseconds to get back, or the other way around. Or even more so, you can't even prove that it doesn't only take 0.01 nanosecond to get down and 3.99 to get back. So with this way of measuring, there's no way to prove the one direction speed of light. Now, this might not sound like it's super important to most of us for our everyday life, but when it comes to the speed of light, this is actually very important. So the speed of light is huge. Here it is written in meters per second, miles per hour, and kilometers per hour. So this is a huge number. And there are many physics equations, laws of physics, and other things that rely on the fact that the speed of light is consistent for them to work. The most famous of these is Einstein's theory of relativity, where E equals mc squared, where c is the speed of light, and that it's assumed that c is constant. So if c is variable, if the speed of light can change, then that means that the energy of particles or even the mass can potentially just change based on this speed. So that's very difficult when it comes to physics. And actually the other real life application, which is what caused me to begin looking into this in the first place, is that there are many people who believe that the Earth and the universe is very young, less than 10,000 years old. And they take some of these discrepancies in science to be proof, or to use this as a reason to explain their beliefs. Now, I don't agree with this. This is not what I believe, but they say that because we can't prove the one direction speed of light, that when we look at stars that appear to us to be billions of light years away, if that light were really traveling much faster than what we really think is the speed of light, then that light from those stars could get here much faster, even in just a couple thousand years. So again, if the speed of light isn't consistent, then maybe those stars really aren't as far away as we as most scientists tend to believe. So I've used all this, and I think I've devised a way to test, maybe not directly test the one-way speed of light, but a way to prove that the speed of light is constant, even as it interacts with objects and as it bounces around. So I just want to give this basic graphic. So my hypothesis is that if you could set up this experiment with a laser that's capable of measuring, that's sending out light and measuring when it comes back, and you set up multiple mirrors, so the light will bounce off of one mirror and then not return, not go back, never repeat, never backtrack, never go back on its path. So it goes to one mirror, to another mirror, and then back to the same device that sent it to record it. So if, according to this, it should confirm whether or not the speed of light is constant. And that's because one of the most basic equations in physics is that speed equals distance divided by time. So if we know that there's a constant distance, if we prove the distance in this, then if the speed of light changes at any point, then it's going to give us a very different time, and it's going to prove a different speed. So especially if you're able to move those mirrors around and arrange them in different orders and give different distances between each step, if you get a constant speed, the exact speed of light that we expect to measure, then this is a confirmation that the speed of light is consistent. And if you prove that the speed of light is consistent, then you've also proven that the one direction speed of light is the same as just the regular speed of light. Now, in order to do this experiment, you might think that it would require some expensive, complex machinery, but that's actually not true. So here in America, you can go to any hardware store, and for $10 or $15, you can get one of these. This is a laser distance measurer. So what it does is it sends out a laser, and so it goes from here to something, and then it because it knows the assumed average speed of light, it actually measures time. So it sends it out and then measures the time that it takes for it to go out and back. And as it measures that time, it knows the distance because the average speed of light is consistent. So if we can just use this just in our home with a few mirrors to set up the experiment. So something very important with this device is that it always displays half the distance that's measured. So this isn't an advanced physics tool. It's not lab-grade physics equipment. It's not designed for this purpose. It's designed to measure, something in your house. So if there's a wall 5 feet away, it's going to send a beam of light 5 feet down and 5 feet back. So the real distance is 10 feet. But it's going to tell you 5 feet because most people want to know that the wall's 5 feet away. The full distance isn't what this thing's designed to measure. So again, throughout all the tests I'm about to show you, it's important to know that the distance, that the device always displays half the distance. So again, I just set up these experiments with mirrors in my home, and so I took videos as I was testing this experiment, but then I also took a picture from above just to give a little bit more clarity to the videos. So let's see how the first experiment goes. All right, so I've got exactly 6 feet between the device and the first mirror, 3 feet between the first and second mirrors, and then 5 feet back to the device, which is 14 feet. So if the device says that this is 7 feet, then that is confirmation of a constant speed of light. 611.5, that's close enough. So I was really just looking for within a few inches here or there to confirm that the speed is consistent. So being less than an inch off was every bit as good as what I could have hoped for. So that one worked very well, and I wanted to change it up. So on the next experiment, I wanted to change to do a bigger variance in the distance between the mirrors. So I wanted one mirror to be really close and the other mirror to be further away. So let's see how this one works. All right, now I've got 3 feet between the device and the first mirror, 7 feet between the mirror and the second mirror, and then 8 feet back. That means 18 feet. So if we see 9 feet would be a confirmation of a constant speed of light. 11.5, perfect. So that one worked very well. So I went ahead and did the exact same thing, just in the reverse order. All right, we've got the exact same setup, different direction. So we've got the device 8 feet away from the first mirror, which is 7 feet away from the second mirror, and then 3 feet back to the device. So that's 18 feet. So 9 feet would be a confirmation of the speed of light. Bang, right on the dot. So as I kept going, I wanted to make it a little bit more difficult by adding an extra mirror. So there's the setup for that, and here's the experiment. I decided to up the difficulty by adding another mirror. So from the device to the first mirror is 7 feet, 6 feet back to the next, 4 feet over to the last mirror, and then 3 feet back to the device. That's 20 feet. So 10 foot, 10 would be a confirmation. 9, 11 and a half. Bang. Exactly what we wanted. So again, that worked just very well. So I wanted to do one more experiment. Here we go. For the final test, we've got 3 feet to the first mirror, 4 feet to the next mirror, 7 feet across the room to the last mirror, and then 6 feet back to the device. That's 20 feet. So 10 is a confirmation. 9, 11, and 5/8. Bang. Perfect. Everything looks exactly like it should. So my wife asked me to apologize for not cleaning up the house better before shooting a video to send out to everyone. So all of these experiments worked as well as I could have possibly predicted. I think that I, beyond reasonable doubt, proved the constant speed of light, and thereby also proved the one-way speed of light. But there were a few little issues with this experiment that I just wanted to explain. So one of them is consistency. So this little tool obviously was not designed for high quality physics experiments. So when I shot out the light, it had to come back to a very, very small receiving sensor, or else it when it was off at all, it gave me very different results. So I actually wanted to show a video of what happens when I did a bad test. So along with showing good tests, I also want to show one bad test. So the device is 4 feet from the first mirror, 2 feet to the second, and then 4 feet back. But rather than going into the device, I want to measure it on my hand. This is actually the way it was designed to work. So the laser bounces off of my hand and then back to the mirrors. So even though the real distance is 20 feet, it should show 10. 10 foot on the dot. That's exactly what I was looking for. So that's what happens when this machine measures the two-way speed of light, not just the one-way speed of light. So, of course, this consistency was a little bit of an issue. You know, I was doing this with mirrors strapped to boxes in a living room with fans, with a fan on the ceiling. So even some of the mirrors were wobbling a little bit. So even some of my results were not as precise as they could have been. I'm sure someone in a big physics lab at a university or some science corporation could get much more consistent results than what I did. Another issue is accuracy. So I don't think this is an issue because the color of light shouldn't change much. And but the only real issue is that the speed of light does change in a vacuum versus in just normal air. So again, if someone's in a lab that can do this test in a vacuum, then this would they would give much better results, and they can, you know, with better mirrors, better lasers, better receivers, would just get just a better result. So one final issue is confirmation bias. So this means when a scientist or anyone else only looks for what they want to see, and they ignore any counterintuitive, any results that are against what they are looking for. So this basically is what I did with this result. I already knew the speed of light. I had already measured the distance, and so I was, you know, using this machine to measure something that I believed I already knew. So whenever it gave me a bad result, I didn't film that. I didn't record that. I just honed it in until it went right. So there might be some confirmation bias for me because I knew what I was looking for, but I promise you there's no confirmation bias with this machine. This little tool doesn't know what it's looking for. It's not smart. It's not programmed to try to do this. All it does is give you the results that it gives you. So I might have been tricked, but there's no way to trick this machine. So again, I don't see any way that I could have reproduced these results and gotten such precise measurements unless the speed of light is consistent, just like we assume. So I don't think that's a real issue, but again, I want to hear from you guys. Maybe I did something else completely wrong. Maybe I'm really not measuring what I think I'm measuring. I want to hear from you guys what you think. So my conclusions. I think I just proved that the speed of light is consistent, and if the speed of light is consistent, then that also proves the one direction speed of light. Because again, if it would have been different at the first or at any other part during this experiment, it would not have given me the accurate results that I got. So again, I'd love to hear from some of you physics-minded people. I'd love to hear some other people confirm this experiment, and I'd love to hear from you guys. But just on a completely different note, my conclusion is that this is awesome. So as a minister, as a Christian minister, it's just wonderful because this light is used as an illustration for many things in Scripture and in the Christian life. So all the way back to the beginning, when God created the universe in Genesis 1, the very first thing that God created was light. The first creation, let there be light, was God's first act of creation. Jesus says in John 8, I am the light of the world. Whoever follows me will not walk in darkness, but will have the light of life. Jesus also said in Matthew 5:16, let your light shine before others, so that they may see your good works and give glory to your Father who is in heaven. This is what I'm hoping to do with this experiment. If this is a good work, I want it to do nothing but bring glory to my Father in heaven. Even in the Psalms, it says that your word, Scripture, is a lamp for my feet and a light for my path. So we talked about light from the very beginning, and now there's light at the very end. So even in Revelation, when we're with God for eternity in the New Jerusalem, it says the city has no need of sun or moon to shine on it, for the glory of God gives it light. So even in eternity, God himself is going to be our light. So again, this is awesome. And if I really did just prove that the speed of light is consistent and just really prove the one direction speed of light is the same as the 2 direction or 5 or 10 direction speed of light, that just blows my mind. If God allowed me to be the one that was the first one to prove this. So again, I'd love to hear from you. If you think I did something wrong, if you want to hear more details of the experiment, write me a comment, send me a message, share it with your friends who really care about physics. I'd really love to hear what other people think. I just want to give a shout out. I couldn't do an experiment with lasers without wearing one of my Star Wars shirts. So again, I do this channel. I try to put out videos regularly, very often on how science and faith interact, plus just many other aspects of faith, life. So if you'd like to hear more, I hope you'll consider liking, subscribing, and following this page. God bless.